Hi class, I wanted to make a pretty short video, hopefully, about exceptions and trying and raising, trying things and accepting exceptions and raising things. So let's start. I want to show an example of something that's done by a standard module called JSON. Import JSON, JSON.loads. So we'll learn about this function pretty soon, but let's just say I put in a random string, and it's supposed to take an especially formatted string, but this one is not getting a specially formatted string. It's getting something kind of arbitrary. By the way, we're looking at the bottom right corner of the screen. Alright, it tells me a bunch of stuff here. The last thing is the thing that ultimately went wrong. The JSON object could not be decoded. It tells me everything that happened up until then. So this is kind of all the different functions that ran. I called JSON.loads, and then default decoder.decode was called on that string, and then raw.decode was called on that. And I can click on any of these and see the source code, or at least most of them, for the particular things. And so you can see here that what happened is it tried to scan my string s, and it came to a stop iteration, which we'll learn about soon. It means that there's no more items left there. And what it's done is it said, you know what, I think they decided that stop iteration was not the appropriate error to display to the user, right? This is going to crash the program. Ultimately, when you put in a bad input, this stop iteration is going to happen. It can't complete its job. It's not going to get to this return statement. But they decided that stop iteration wasn't the appropriate message to give to the user. If they had not done a tried and accept, right? If they had just, if they comment this out and they just run this line and assumed this, sure, the code would have stopped. But what would have happened is a stop iteration would have left raw decode and probably ultimately come back and be reported here. And so instead of saying value error, no JSON object could be decoded, which is what happened. This here was not a specially formatted JSON string. It couldn't be decoded. It would have reported some like stop iteration exception. And then it's like, well, what went wrong? Why was there a stop iteration exception when I put in a string? I thought I was supposed to put in a string. Yes, but a value error is more appropriate. The particular string that I put in couldn't be decoded. So it's doing the try. It's encountering a stop iteration, and it says, hey, that's not the appropriate thing that the user should see. I want to raise a value error with this particular message, right? So that helps. It's one example of how try except can be used, and this is an example of where you might want to raise something. And you can do this, with other modules. Not all modules will let you see their code, but for many times, if you encounter it, you can see all the chain of things that got called in this information, and then you can usually click in and see the particular line of code. So I suggest you might do that if you run into an error that's maybe confusing. You can always click in there, or if you just want to see an example of how errors are used. Here's another example. I guess we talked a little bit about using writing our own map function. So let's say that we want to have a map function that takes the square of all the numbers. So it's going to work kind of like map. So if we put in map f and range 10, we would expect to get the squares of all the numbers 0 through 9, which we do. And we wanted to write our own function, so we write our function like this. We'll accept an argument f, which is the function, and l, which is some sort of sequence or iterable, and we'll use list comprehension to return the list that we want. And so if we run this, it works just fine. Here, let's just print this instead of assigning it to a variable. Great, so we get the same output. Now what happens when we use the map function and we put in not a function, just put in 1. Let's see what happens. Let's see what it does. Type in object is not callable. Okay, let's see what our function does for that. Okay, it looks like we got basically the same sort of type error. That might be a good message int object if the user didn't realize, like, if they had code that was like way back here, they had defined x gets 1, or maybe they said f gets 1, and then they had f here, right? They think, oh yeah, f, well, and they forgot that, oh yeah, here, this might do the trick. Redefinition of unused. Yeah, I think that's it. Let's say they didn't get that warning. Look at this. It's like they say, oh look, I defined my f of x, and then I put my f in here. What int object is not callable, right? They might not notice that they accidentally had put this somewhere else in the code. This is part of a much longer piece of code, right? So maybe type error is not that's the right kind of error, but maybe you'd like a more detailed message. They did give a more detailed message when you mess up on the second input, so let's fix what we've done here. Let's see what sort of input, what sort of thing happens when you put in, so this thing here has to be iterable, right? We have to have a sequence, something we can go through, but what if we just put a number there for x in 1? Okay, we get again, int object is not iterable, and we could have the same sort of thing where, you know, they intended for x to be an iterable thing, and unfortunately it wasn't defined as an iterable thing. But what does map function do? Let's see what map does when you use f and just 1. Oh, argument 2 to map must support iteration. Now that's pretty helpful. It says the second thing you put in is the thing that's causing the problem. It needs to support iteration. Apparently it doesn't. So let's see if we can achieve that sort of behavior with MyMap. So what we'll do is maybe we'll do this, yeah, here, we can put a try in here. Okay, and then we'll do an except. And we can take a look at the message that's inside that type error. So we'll accept a type error as e. So e is our object. It's got a message inside it. And then we can say if e.startswith, e.message, excuse me, .starts with argument. No, it's not going to do that. It's going to give us the int object is not iterable. Then we should return a type error, except with a different message, argument 2 here. So we're just changing the message basically to something that's more specific to the function. Like, sure, our function will exit, it will return a type error, or excuse me, raise a type error, but we want to change what the message is. And so we're going to put it in a try-catch block. We're going to find that type error, and before it exits to the user, we're going to return a different kind of type error, or one with a different message. So let's see if our MyMap now is going to work like that. Okay, it looks like we've got a deprecation warning. We're not supposed to be using .message anymore, but let's ignore that for now. So it's giving me an additional warning, but all we really care about is that it's actually raising argument 2 to map must support iteration. Oh, but that's not what I meant to do. I meant to raise the type error, and that's why I'm not getting the callback. There we go. Argument 2 to map must support iteration. That's what we intended to happen instead of return. And let's go back and actually change that there. So let's see, what was the error that we were getting here? We were getting a, whoa. Oh, so it looks like here, look what's happening now. We tried to print MyMap. It's accepting the type error as e. So we know that when we put in a 1 here, we were going to get a type error, and it was going to do something like, what did it say? Int object is not callable, right? So let's go ahead and do the same sort of thing. We can do on elif e.message.startswith, or we could say is equal to. If the int object isn't callable, we know that really means that, what do we say? Argument 1 to map must be callable, like a function. But we don't want to specify that it has to be a function. It could be a member function, it could be a lambda function, so maybe the user would get confused if we just said function. So callable is the more general term. And it's also, it's not a particular type that it has to be, right? It must support iteration. We're not saying it has to be a list. We're not saying it has to be a set. It can be anything that supports iteration over it. Must be callable. We're telling what it needs to be able to be done with it, not what it has to be. So that's another Pythonic sort of thing. And then finally, else, like what if something else went wrong? Well, we don't want to just return. See, what happened before is let's see what happened. I'll show you again. Before, I didn't mention it, but before I had that, and I put passed in 1 here. Look, I get this. Forget about this deprecation warning, but it's returning none. Why is it doing that? Print my map, so it's printing whatever my map returns. We got it. Apparently, my map is not returning anything. It's accepting the type error, right? And then there's no return. It's finishing. It's like, oh well, it didn't start with in object is not iterable. So it gets down to here. There's no code down here, which is basically the same thing as having return, which is basically the same thing as having return none here. That's what happens when you have a function that gets to the end and it doesn't explicitly return something, it implicitly returns none. And so that's why it's printing none, is because it's finding that type error. It's saying, oh, we're okay, we've handled it, even though it didn't satisfy this if statement. It says type error is all right. We'll put whatever we need to do in here to protect ourselves from whatever's going wrong, and then it's implicitly returning none. So we fixed that by doing that. But now, what if something else were to go wrong? Would we want it to return none? No. Let's put an else in here, and we'll just re-raise whatever happened. And that's probably a better way to write this function. So now argument 1 to map must be callable, and let's see if we put in f, and we put in 1 over here. That's another mistake. Argument 2 to map must support iteration. To be honest, I think we've improved on the map function here. And the final example I wanted to give you of using try except was this example. So I wrote some code for SciPy, which is what some of you who are taking track A will see. SciPy, Scientific Python. It's a bunch of applied math techniques for use in science, in all sorts of science and math. I wrote this function called Lin Prog. It's for linear programming. You might have learned a little bit about that in high school, but we see much more advanced and large problems, and so there's a little bit more to be done than the graphical methods you might have learned in high school. But this function, Lin Prog, needs to take in a bunch of arguments. One of them is C, which should be a vector in the sense of a math vector, kind of like a one-dimensional matrix, if you will. And A, U, B, that's a 2D matrix. This is a one-dimensional matrix, a two-dimensional matrix, and when I'm saying one and two-dimensional matrix, I mean it is a two-dimensional length matrix, but one of the dimensions has a length of 1. That's what I mean by one-dimensional. Alright, so it's taken a bunch of arguments, but the problem is the user could accidentally put in a scalar, or the user might accidentally put in a two-dimensional matrix in place of C, thinking the order of the arguments is different. The user could put in a sparse matrix, which is a different way of storing the data. They could put in a list, or a list of lists. And I should be able to work with even lists, because actually what I'm going for, the C, should be a one-dimensional matrix. It should be coefficients of the linear objective function to be minimized. One way of looking at it is 1, 2, 3, 4, 5, 6, right? just a list of numbers. Now I don't want a list of lists. Because that's a two-dimensional. This can be visualized as a two-dimensional matrix. I don't want a string. I don't want those other types. So I'm not 100% proud of this code, but it works really, really well, this particular part here. So what I do is I start out by trying something, and I've got a big block, and I'm not going to go into the details of how it works, but it's very careful to allow into the function whatever will work and tries to make smart decisions about it, and will try to reject and provide a good error message as to what the user did wrong whenever what the user entered is not going to work. And so you can take a look at this logic. We've got even nested tries. You see that I'll accept a type error and again re-raise a type error with a different message. Here I'm raising my own value error in case there's something wrong with the values, right? So if there are infinite values inside my list here, I think there's a math.inf import. Math.inf. Oh, no. Well, there's definitely one in NumPy. So this is representing infinity. And so you see, oh, there's also float inf. Oh, I did not mean to go all the way down there. Let's get back here. Okay, so it's checking to see if there's something infinite, right? So if I'd included, accidentally, probably, that in the input to the function, that's not okay. I'm not going to be able to work with that. And so rather than some error, eventually this infinity is going to cause an error somewhere in the algorithm, but I said, hey, let's catch it right now before running any code so that we don't get deep into the code and show the user when something eventually goes wrong, this really long stack trace of all these things went wrong. No, it's going to say, as soon as you went into the function, you provided an input that had a bad value in it, and it's specifying that it can't contain that sort of value. Alright, so again, not going through the logic in great detail, but you can take a look at the different things that are checked. In some cases, I'm trying to do things, and if I fail, then I'm going to return with an error message. In other cases, I'm checking explicitly if some things are true. So there's a little bit of a mix of look before you leap and beg forgiveness rather than ask permission. So there's a mix of those things going on here, but in the end, while it's not the prettiest code and may not be the most efficient way of doing it, it's pretty bulletproof. I tested it with a lot of different inputs, and it does exactly what I wanted it to do for each of those. So that's yet a more advanced example of uses of try, accept, and raise.